So with that, I'd like to go ahead and it's my pleasure to introduce today's panel of speakers. Marcel Moreau has worked exclusively in the field of underground storage tanks since 1983. His experience includes 4 years with the Maine Department of Environmental Protection and 4 years with an environmental engineering firm. Since 1991, he has been an independent consultant providing information services to government, industry, and private sector clients. Ben Thomas has over 30 years of experience explaining UST rules to operators, inspectors, and technicians. First as a state inspector in Vermont from 1986 to 1987, and then as an inspector in Alaska from 1989 to 2002. And then as a consultant, Ben has been providing UST operator training nationwide, both live and online, since 2002. John Kelly is the founder and CEO of Canary Compliance, a remote UST monitoring technology and leak detection analytics company. While working for ExxonMobil, John heard his customers complain about a lack of reliable, data-driven, and cost-effective remote UST monitoring solutions, so he started Canary Compliance to address their problems. Justin Whitfield is a business analyst at Canary Compliance. Justin started his career in the industry as an inspector in the state of Texas and then spent 4 years working in 7-Eleven's environmental department, handling the day-to-day compliance operations of nearly 500 stores. My pleasure to welcome our distinguished panel. Thank you all so much for being here to present today. We really appreciate it. Before I hand it off, hopefully you saw on the website leading up to this the training overview. So briefly here, we do today plan to discuss automatic tank gauge basics, information on being in the field, how do owners and operators use the automatic tank gauges as well as regulators. We're going to discuss alarms and response. And we're also going to be discussing reporting today, what's considered valid reporting from an automatic tank gauge. So I will leave it to our speakers to get into depth on the topics. And with that, it is my pleasure to introduce our first speaker, Marcel Moreau. And Marcel, I'm going to hand you the controls now and take it away when you're ready, sir.
I think I'm ready, Drew. Am I live audio?
Yes, you are.
Okay, very good. Let me just see if I can. All right. We didn't beginning here. There we go. So we have automatic tank gauges. So the story of automatic tank gauges goes back on the order of about 35 years or so. And the primary function of the original automatic tank gauge was basically to try and eliminate or reduce our reliance on the former technology, which was the wooden stick. Now, wooden sticks have been around for like 50 years or more, and still in the middle 80s, they were the primary and pretty close to the only method that people were using to find out how much fuel was in their underground storage tank. Now, there are a lot of issues to recognize with sticks, the primary one being how do you get people to use them, and then how do you get them to use them correctly, and then how do you get them to use them regularly. On a nice day, going out to stick a tank is probably not such a big deal, but in the cold of winter or heat of summer or in the middle of a thunderstorm, tank gauging is not the most fun thing in the world. Plus, the accuracy of a wooden stick leaves a lot to be desired. A lot of that has to do with the conscientiousness of the operator, the person holding the stick. But there's still even difficulties in reading a stick based on how dry it is or how wet it is or how dark it is. So there was a lot of room for improvement, and developers of the automatic tank gauge were hoping that they could address this problem. But the basic tank gauge consists of a console, which is a box full of electronics that sits on a wall, usually inside a facility, and a probe that is inserted inside the underground storage tank. And I want to start by looking a little more closely at the probe. So virtually all probes today are magnetostricted in nature, called mag probes for short. This has proven to be a very reliable, very accurate, very stable technology to use in underground storage tanks. There's a couple of others that are out there, but they're collectively only a few percent probably of the probes that are out there. So I'm going to focus on the MAG probe or magnetostrictive probe. Let's start with a cylinder at the top, which basically has electronics in it. We won't get too far into what those electronics consist of. And then there's a rod extending below that, and that goes down from the top to the bottom of the tank. And on the rod, there's a donut-shaped float, one that floats on the product. And very important is that that float incorporates a magnet. There's typically also a second float designed to float on any water that might be present in the bottom of the tank. So it has a slightly different density than the product float. There's also within that rod, which is a hollow rod, there's a thin wire that runs down the center from top to bottom and is fastened at both ends. The way that the probe takes a measurement is that a short electric pulse is sent down the wire. And if you might remember in physics class, anytime you have electricity flowing through a conductor, you generate a magnetic field around that conductor. So we have a pulse that's very brief magnetic field down the length of that thin wire in the middle of the probe. So the magnetic field around the wire interacts with the magnetic field created by the magnet that's in the float, right? And this interaction of the two magnetic fields causes the wire to twist very slightly. Okay? That twist then travels up the wire. So that little tweak in the wire travels up the wire and is sensed by the electronics. Now, how fast that twist travels along the wire was measured at the factory when the probe was made, and we know that speed of travel very accurately. Right? This is the calibration factor that is unique to every probe. So what the probe does is it measures the time from when the electric pulse was sent to when that little twist in the wire arrives at the electronics. And that time, based on the travel time of that twist on the wire, now is converted to a distance. So the distance from the float, all right, to the electronics is subtracted from the length of the probe, right, to give us the depth of liquid D. And that depth is known very, very accurately, down to about thousandths or 10,000ths of an inch. So this, and it's very reproducible. So this is why magnetostrictive probes have come to sort of dominate the industry. Within the probe, there are also little devices called thermistors. And thermistors measure temperature. Their electrical resistance changes with temperature. So by measuring resistance, we can tell what the temperature is at the location of the thermistor. Typically, there are 4 or 5 of them located along the length of the probe because we need to get a vertical profile of the temperature. Temperature is not the same from top to bottom in a typical underground tank. Colder product tends to settle to the bottom. Warmer product rises to the top. So if we're going to get an accurate picture of what's happening along the length of the tank, we need to have different measurements made at different heights, and we have to assume that the temperatures are horizontally consistent along the length of the tank. And that means that the product basically has to have been still for a while. So this is the primary reason why we don't get good temperature information immediately after a delivery, because that product has all been stirred up. And we need to wait a couple of hours for that temperature profile to develop and for us to get an accurate idea of what the entire throughout the tank might be. So that's what's going on with the probe. All right? So back at the console, console is where all of these sort of data management and data analysis is being conducted, or data transformation is being made. All that the probe is giving us is basically the depth of the liquid, both water and product, and also the temperature of the fuel. All the other calculations are happening inside of the tank gauge console. Some common abilities of tank gauges include the following. So they give us the product level, which we just talked about. They give us the gross volume, which is the number of gallons that are in the tank. And while the product level is known very, very accurately, the accuracy of the gallons present degrades somewhat because we don't know precisely the length of the tank, the diameter of the tank, whether the tank a little bit or whether it's perfectly round, whether it's tilted in one direction or the other. So there are some errors that creep into this calculation of the gross volume, but overall we're a whole lot better off than we were with the wooden stick. Most tank gauges also give us the net volume, and that is the number of gallons that would be present if the fuel were at a temperature of 60 degrees. So the gross volume is however many gallons are present in the tank at whatever temperature the fuel happens to be. The net volume is temperature compensated so that it gives us the volume of fuel at 60 degrees. That typically doesn't come into the operation of a typical gas station very much, but when tanker loads of fuel are being bought and sold, those transactions are typically done on the net volume. And this is because the volume of gasoline changes significantly with temperatures. So in order to have a level playing field when you're transferring large volumes of fuel, people like to do or deal in the net volume rather than gross volume. Tank gauges also give us the water level from that water float that we talked about, and they convert that to water volume, although again there's some errors there. And also it takes a certain amount of water for that float to actually move off the bottom of the probe, so that first half to 3/4 of an inch is typically not measured by the water float because it takes that much water before that float starts to move off the bottom. The tank gauges also give us the ullage volume, the volume of the empty space in the underground storage tank. So if you had a 10,000 gallon tank, 6,000 gallons in it, the ullage volume would be 1,000 gallons. They also typically give us something referred to as the 90% ullage, and that's the volume of liquid that it would take to bring the volume of fuel in the tank up to 90%. So if we had 6,000 gallons in that 10,000 gallon tank, the 90% ullage would be 3,000 gallons. And that's a handy number for a tank owner or operator to have because it tells you how much fuel you can order that will comfortably fit in that tank without getting too close to the top and getting in refill territory. You can also have high and low product alarms. High product alarms can be used for overfill prevention if they're connected to an external alarm, and it's going to notify the driver. And low product alarms will tell you that it's time to order some fuel. There are high water alarms to tell you that you're in danger of pumping water or phase separated product into your customer's car, so that's something you want to pay attention to if you're the owner or operator of a facility. The ATG can tell you when you need a delivery, when you're getting low on product, and also give you a calculation of the delivery volume based on tank gauge data. So when the fuel level starts to go up, tank gauge says, oh, delivery going on, makes a note of what the level is, makes another note of what the volume is when the fuel volume stops going up, and then uses those two data points to calculate a delivery volume. Again, there's some errors in that calculation, as we talked about before, plus there's additional errors if fuel is being dispensed during the delivery. So this is a good number to use as an approximation, but it's not the number that should be used if you inventory control. You should use your delivery receipt for that delivery volume. From our perspective, what's of interest about that is their ability to, they can do both mostly leak detection, which is ability to identify leaks of 0.2 gallons per hour, or they can also do tightness testing, which identify leaks of as small as 0.1 gallons per hour. There's two basic methodologies that the tank gauge can use to conduct a test. The first one is generally referred to as a periodic test. In a periodic test, no product can be dispensed during the test period, which generally lasts several hours. Right? Typically, this type of test is done when the facility is closed, oftentimes overnight. Now, if the facility is open on an unattended basis overnight and is doing periodic tests, and somebody comes by and pumps fuel while the leak test is going on, you'll probably going to flunk that test, and that will be a failed test that the owner-operator should have to explain the next day. The other methodology is continuous testing, and that was developed for folks who didn't want to shut down at night, want to be able to deliver or pump fuel on a 24-hour basis. So continuous testing isn't really continuous, but it does allow for continuous or uninterrupted product dispensing. Right? So the tank gauge monitors for periods when there is no dispensing activity going on. And if that period is long enough, typically on the order of 15 minutes or so, then it gathers a certain amount of data regarding how stable that liquid level is in the underground tank. Over time, the tank gauge puts together a bunch of different test data intervals until it has enough information to conclusively say that a tank is leaking or your continuous automatic tank gauge. All right, so tank gauges, like computers, can have a lot of different devices added to them to give them different capabilities. So a lot of tank gauges these days have sensors attached to them, and sensors can be used to monitor the interstitial spaces in tanks. They can be used to monitor submersible pump sumps or under dispenser sumps. So you can use your tank gauge to meet interstitial monitoring requirements if you have appropriate sensors installed. Types of sensors include non-discriminating sensors. They're the simplest kind and very common out there. And basically, they tell you whether there's liquid present or not. It tells you the difference between nothing and something, but it doesn't tell you whether that liquid is fuel or water. So you physically need to go and look to see what's happening if you have a non-discriminating sensor. Discriminating sensors, on the other hand, have the ability to discriminate between water and petroleum. So they tell you whether a sump is dry, water is present, or petroleum is present. And those are less common, although I think they're becoming more popular as time goes on. Third type of sensor is what I consider to be the ineffective sensors. They're only going to work if they're properly positioned, and that generally means that towards the bottom of an underground tank or the bottom of a sump. And also for all the float-based sensors out there, they need to be vertically oriented. And I think those of you who are inspectors are quite familiar with the fact that sensors are not always properly positioned. So, and if they're not properly positioned, they're not going to do their job. They're not going to tell us what's happening in that underground space. So hopefully more frequent inspections and testing of sumps is going to help reduce the magnitude of this problem. Sensors operate on a number of different principles. A lot of them have little floats that go up and down on rods. There's some optically based sensors. That upper middle sensor here is an optical sensor. Others use electrical resistance as well. We haven't got the time to get into all of the different operating principles. But a while back, I wrote an article in Technically Speaking called Making Sense of Sensors. If you go to the NEIWPCC website and look at the Westline archives, you can read all about sensors and how they work in this article. Another peripheral that's quite common on automatic tank gauges is the line leak detector. So the original automatic tank gauge just told you information about what was happening inside the underground tank. But it didn't take too long for the line leak detector to get connected to the automatic tank gauge so that the ATG could also give you information about what was happening in your product line. Most of the line leak detectors are pressure sensing devices, so they monitor the pressure in the line to give us information about what's going on there. Line leak detectors typically serve the function of the line leak detector required in the regulations, which is to find leaks of 3 gallons per hour. Many of them are also able to do 0.2 gallon per hour leak testing so that they can meet your monthly requirements as well as your line leak detector requirements. Again, we haven't got a lot of time to get into operate, but there's another Westline article from 20 years ago now called the Blabbermouths and Tattletales, which is also available in the Westline archives on the NEIWPCC website if you want to learn more about both mechanical and electronic leak detectors. An arrival on tank gauges is remote communications. The original devices basically were standalone devices. In the early 90s, they sort of plugged into phone lines and modems, and then in more recent times they're wireless and connected into the internet, so that a tank owner can find out what's happening in his tank from pretty much anywhere in the world. Technicians can also do some troubleshooting remotely, and operators can find out what's happening from pretty much anywhere. So Ed Canary are going to tell us a lot more about remote communications when they're up to bat here in just a few minutes. The many different flavors of automatic tank gauge, many different manufacturers. The features that I've talked about here are common to pretty much all of them. Ben Thomas, the next speaker, is going to talk about how to differentiate some of these different types. But basically, the tank gauge is a tool. It's much more sophisticated than the old wooden stick, but it's still a tool. Like a hammer, you can use it to pound nails, or you can use it to pull nails. You can use it to pound things together, or you can use it to rip things apart. And different people, operators, regulators, technicians, have different uses for tank gauges that, again, our next speaker, Ben, is going to talk about. So that's it for my presentation. If there are any questions, I think Drew is poised to ask them now.
Yeah, excellent. Thank you so much for the comprehensive overview and the start to the training today, Marcel. And yeah, with that, again, encouraging any and all questions. So far, I haven't received any, but I do just want to give it at least a minute or so to just kind of wait to see if we get anything in from the audience. And just a friendly reminder again to everyone out there: no need to wait to ask questions. For these Q&A periods, as things come up on the slides as they're discussed, feel free to fire them at me. And you do that by again just opening the chat function. For those of you who haven't been on the webinars before, if you scroll to the bottom center of your presentation screen, you might need to click, but some buttons will pop up for you. Click the chat bubble, kind of like the little voice bubble, and from there you can communicate questions to me, the moderator. So I'm going to give it another 30 seconds here and see if anything comes in for Marcel before we move right along. So fire away. So I'm not seeing anything come in yet, and that's okay. Just getting started here. Again, as any questions come in, please feel free to send them to me, and we'll get to them throughout the training as we take Q&A. So feel free to send them my way. All right. Well, thank you again to Marcel for the introduction, and we'll obviously keep the whole panel involved with the questions as they come in. So Marcel, a question might come up for you later in the training. So
okay.
With
I'll be standing by.
All right. Thanks so much, Marcel. And it is now my pleasure to go ahead and hand it off to today's second speaker, Ben Thomas. And Ben, I'm going to pass you the controls now. And when you are ready, please take it away, sir.
Thanks, Drew. How's my voice coming through, okay?
Very good. Yep.
Okay. So welcome, everyone, to today's webinar. It's a treat to be here, given the fact when I think back to 1982, when I was what we now call a Class C UST operator. I was a gas station attendant at an all-night rest area gas station on Interstate 95, and I was basically just handed a stick. I was handed a one-piece dark blue suit, and like here's the nozzles. Sell gas. Here's the stick. I was actually taught to stick a tank by my supervisor, who jokingly would stab the stick into the bottom of the tank, and the joke was to see how high the stick could pop out of the ground. So, back in the good old days, no tank gauges, no concept of what we were doing. The smart stuff Marcel was talking about, even at a corporate level company, it just simply wasn't passed down. If you're kind of new to the UST inspector world, I just want to kind of give you an appreciation for how far we've come in the last 30 years. The automatic tank gauge is really a super cool instrument. It's the one thing that I think a lot of tank operators somewhat identify with. And so I'm here today to talk about purposes, perspectives, potentials and positive identifications. But the key word I want to offer to inspectors today is perspectives, because I think what the inspector sees and thinks the operator sees at a tank gauge may not be the same as what the operator sees. There's a day-to-day functionality that the operator needs simply to keep the gas station or the tank system running. The inspectors have a series of things they need to kind of verify, and so I'm hoping that through today's talk you can kind of be thinking about, I guess I'm asking you to kind of think about what the operator sees as an inspector, and once you kind of get a handle on that, you can offer some additional points to try to increase their worldview about what the automatic tank gauge is. Let's get my clicker going here. Yeah, so I've been doing UST work a long time, like I said in the introduction, formerly as an inspector, and then now as a UST consultant and trainer. I think my particular interest is the intersection of the technology, what motivates people, and then management, because with UST compliance, it's not just about people, and it's not just about the management or the technology. It's kind of the triangulation of the three. So I'm hoping to be able to offer kind of a varied perspective on this. So going to be kind of recapping with maybe different words some of the purposes of the automatic tank gauge, because again, with the perspective of the operator and prospector, it can be quite a bit different. Marcel and I have talked about this for years about how these two different populations see the same thing, and if we can maybe find some common ground, we can improve compliance that way. Again, like I said, what the operator sees and what the inspector sees are somewhat different, and the automatic tank gauge gives the inspector a great window into compliance potential of the site. We'll talk a little bit about that. And then I'll lead in with some kind of funny pictures about what bad automatic tank gauges look like in the field, and then we'll talk about maybe some hints about how to identify yours in the field, because what's going to happen is you're going to, like Marcel said, there are many flavors of tank gauges. There have been a couple of popular flavors that have risen to the top, in particular Vito and Incons, but there's a lot of tank gauges out there you're likely to come across, and so it's good to be familiar with a wide variety of them. So the automatic tank gauge is many things. It's a multi-purpose tool that can do many things, so it's not just about, like Marcel said back in the day, it was just really about capturing liquid level measurements. It can do a wide variety of things, and many times the operator is not aware of all of its capabilities. I like to think of the tank gauge as the brain of the system, and so it's kind of the central point that operators can focus on to know that they can gather critical information for compliance inspections. And therefore, it is the box that consolidates important information. It's kind of the go-to point to verify compliance, and it's essential that operators know how to run them and inspectors know what to look for. And the tank gauge, ATG, is something that the operator uses to manage their system. It's more of a tool for keeping the business operation going first and the compliance second. The inspector sees it, I think, strictly as a compliance tool. So again, being able to think about an operator perspective is helpful. And like Marcel said, many flavors out there. There's many shapes, sizes, colors, and even software versions. So you can look at this, Vito TLS 350, and there's actually, say, 12 different probes that could be associated with them. So just because you see one box doesn't mean you can account for all the variability of hardware and software in the system. And so when I talk to operators, I don't always say automatic tank gauge. I'll say, hey, can I see your Vito route, or can I see your Incon, your Evo? And Marcel tells a funny story about going to a site and asking to see the tank gauge, and the guy goes, oh, you mean that loud thing in the back room? I think, John, you've kind of used that joke in some of your commercials as well, because that's how the operator sees it, as almost this kind of irritant thing that they don't quite know what to do. Sometimes I'll ask to see the tank monitor, and the person will say, oh, you mean the automatic tank gauge? And so they actually maybe know more than I thought. Or some people just simply call them the tank monitor. So even the device itself comes in a whole variety of names. And so when you're doing a compliance inspection, it's good to kind of figure out the range of the language of the person you're talking to. So what the operator sees are things kind of like some of the things Marcel's have covered. They're making sure the tanks are full enough so they can keep an operation to sell fuel. So, critical thing for a tank operator is just to simply get a good inventory control measurement. You can measure water as well, and this is becoming particularly problematic. When I do AB operator training, I talk about the importance of measuring water and the lack of water when you've got ethanol formulated fuels. And so a lot of times operators don't necessarily know that there's a two-float system out there. And you can also, from a business perspective, the tank gauge can provide the operator has important business sales activities. They can see what fuel's selling the most. They can see what dispensers are the most profitable. That is beyond the scope of what an inspector needs to know. But again, you know, an operator can see this as a business tool as much as a compliance tool, and they can use it for things like ordering fuel and then receiving fuel, because the tank gauge will give a printout of the delivery once the delivery is done. If you're a state that requires to do inventory control and you really don't want to use a stick, which you probably shouldn't be doing in the first place, the Vito or the tank monitor can take the place of the stick and provide critical inventory information so they can use it for either inventory control or for SIR. A lot of operators I talk to, you know, when they see the blinking red light, even if there's a readout that says what the alarm is, they're not entirely sure what to do with it. In fact, I've seen the blinking red light intimidate more than one operator out there. But they do know that the thing can be blinking. I mean, kind of a quick funny side story. I made a little sticker that operators can put on their tank gauge, and it says, "Am I blinking? Am I beeping? Please call." And then you can put down the supervisor's number, trying to get people to kind of be thinking about, okay, so there's blinking red. That's actually a call for action. And so I went to a local gas station where I live here on Whidbey Island, Washington. I literally went to this tank gauge that's on the screen, and I wanted to hold up my prototype sticker to see how it looked like, and the thing was an alarm. And the operator said, well, yeah, you know, it's kind of this alarm. And the operator had been around for 10-plus years, actually didn't know what the alarm meant. And there were 3 sump sensors in alarm. And so even with all this technology experience, the operators still don't necessarily know what to do with the alarm information. And also, operators do know that the thing does this daily or weekly or monthly printout and can give us leak detection information. There's our friend Marcel here on the screen. This is an inspector class we did. Marcel, I can't remember what state this is in. This might have been Kentucky or Tennessee some years ago. From the inspector's perspective, it's a totally different creature. We want to be able to verify interstitial monitoring compliance. You know, does it have sensors, and are they an alarm, and are they keeping interstitial monitoring release detection results? If you're doing a leak detection result for the tank, you can also verify compliance information that way. You can verify whether there is a electronic line leak detector, and to what levels they're testing, and how they've been doing. And if good inspectors ought to be able to get in and search the alarm history, and you can go tank by tank and alarm by alarm type and get a complete alarm verification history. Setup is also really important. Verifying setup or the third-party certification. Has the tank gauge even been programmed properly? We find many tank gauges out there, if they're misprogrammed, they can give us misinformation, and then compliance is certainly up in the air. You can verify whether the overfill alarm has been set to 90 or 95%. We sometimes find that's been changed. And you can verify whether or not the sensors are hooked up and functioning properly. So again, this is more kind of a verification perspective of inspectors, and the operators are just simply more of a operator perspective. I'll just do a quick recap here. So if you can use the ATG to determine things like in-tank monitoring, like CSLD or 0.2 or SIR. You can use the automatic tank gauge. A lot of operators don't fully appreciate the fact that they can look at all these things at the same time. So they can do line pressure if they got PLLDs. They can do interstitial monitoring and in-tank monitoring as well. And as you probably know, the in-tank monitoring can be a variety of things. It can be the 0.2 gallon per hour periodic test, daily, weekly, or monthly, or if you've got Vito or if you've got Incon, you can do continuous monitoring. And if you're doing SIR, you can also use the in-tank monitoring results to give to an SIR vendor so that they can, in fact, perform SIR test results. As well interstitially, and again, a lot of operators, you know, they can see an alarm and go, L3 fuel alarm, and then they don't quite know what it means because they weren't aware that they actually had a double-wall tank in the first place. And so you can have sensors in the interstitial space of tanks and piping, and those sensors can be used for dry, hydrostatic, vacuum, or pressure interstitial monitoring. Likewise, too, you can go to a tank gauge, and again, most operators, if you ask them point blank, especially the moms and pops, if you were to say, do you have an electronic or a mechanical line leak detector, they're not entirely sure, and they're not necessarily aware unless they took the AB training that there's 3 different levels that can be programmed. I see a lot of PLLDs or electronic line leak detectors that are only programmed for 3. Some are 3 gallon per hour and 0.2. Every once in a while I come across them that also are scheduled to do an annual 0.1 gallon per hour test. So again, until you get into the tank gauge and start kind of looking at the setup of the test results, you don't know if you're looking for what I tell operators as a big small and tiny leak. Outside the realm of strict leak detection, you can do things like verifying high-level fuel alarms and low-level fuel alarms. Low meaning you need to keep your tank full. High, you want to make sure you don't run the risk of an overfill. If a sensor or probe are available, you can go into the function button and determine which ones are out there. And sometimes they're, depending on how they're labeled, a good inspector ought to be able to use the tank gauge to verify the presence and connectivity of the probes. And so, are the probes there? Are the sensors there? If the probe or sensor are out or malfunctioning, that should be listed as a warning as well. So you can determine you can identify which is which and determine the functionality. I will say that I've only, out of the thousands of tank gauges I've looked at over the years, I've come across maybe one or two that actually have a key that say L2 sensor equals, whatever, super unleaded, L3 sensor equals diesel sump and things like that. And so as an inspector, you got to kind of hunt and peck because the operator couldn't tell you off the bat what an L2 sensor was and where it was relative to what's underneath the tank pad. Good operators can also dig in and get alarm and test result histories. The newer tank gauges give us a kind of a one-button printout here, but with a tank monitor, you actually have to get into the alarm history and start either sorting by tank at a time or by alarm type. And so it takes a little bit of drilling down to get all the information that you need. So here's a pro tip, and if you're a seasoned inspector, you probably know this. If you're new, go to the Vito Function button. I tell this to tank operators all the time, and they love this feature. And say go to function and just start hitting the function button, and it'll tell you what is in the tank gauge system. And so you hit function. All of a sudden you hit a thing that says 0.2 gallon per hour test. And so okay, well, at least we're doing a periodic test. Next function button, it might say CSLD. Now, another sub-pro tip here is that if you've got CSLD at a site, you're actually going to see both in the function. So you're going to see 0.2 gallon per hour test, and if you hit the step button, it'll show it as blank. But if there's also CSLD, that will be included as well. And so one of those kind of weird little dog legs you got to fish through when you're looking at a Vito route is that if it's got CSLD, it's going to give you like a blank function before that, which is the periodic 0.2, and then the next function will be CSLD. And as you scroll through the function button, if you hit a thing called liquid status, that's actually can tell you whether or not there's interstitial monitoring. So if someone calls me up like, I don't know if I have double wall tank or not, I tell them to go online, go to the tank gauge, hit the function button a couple times, and if it says liquid status, hit step, and then you can get a printout of all your sensors. Likewise, if the next function says start line pressure test, then you've got PLLDs or electronic line leak detectors. But if you're playing with the function button at a tank gauge, always make sure you go back to the all functions normal, because the function button will start off hopefully as all functions normal and then circle back to that originally. So use this as an educational tool to help operators know how they can figure out what's under the hood, because as you know, every tank gauge is a little bit different number of tanks, different number of functionalities, different amount of input relays. When I talk to tank operators, I like to say the ATGs can tell us the past, the present, and the future. So the ATG can tell us an alarm history, what happened. They can tell us what's happening now in the present, functions and conditions, what's happening now. And they can do future forecasts and say what will happen based on the programming that it does. A good inspector, when they first go up to a tank gauge, I like to kind of do just a quick assessment here. I'm looking at this picture here saying, okay, so this is an older ecosystem. It's no longer manufactured, and someone has put a giant Sharpie instructions on there to say, so there's some kind of crude instructions. So someone's trying to make sense of this. Unfortunately, the panel door is ripped off, and there's a bucket underneath there, presumably either to catch rainwater or to maybe catch the printouts here. But a good inspector, you want to be able to note the brand, the model number, the overall condition. This one doesn't look too hot. Internet connectivity, is there a DSL or a canary cable coming out of there? Does the thing have power? I still come across tank gauges that don't have power. And what is the current alarm status? So this is kind of your first tier consideration when you're looking at a site. There's a great picture here, and you can tell how often this Vito route is used because it's up on the ceiling and it's hidden under a couple $100 worth of soda pop here. So again, are the lights working? Is there paper in the printer? Are there any special notes? I tend to have a soft spot for operators who put little Post-its on tank gauges because it shows an intent of them trying to kind of figure stuff out. And so I look for that. Every once in a while, I'll see a user guide. Vito and Incom both have great user manuals, and if those are there and they're all smudgy with fingerprints, then you know that someone is trying to make good sense of that. But really critically is to make sure the tank gauge is accessible. If it's blocked, if it's got access or security issues, that can be a problem with operations and compliance as well. Just a couple of quick shots of photos I've taken over the years. This Vito on the left is taken in the office, it's actually the back office. The company was so cheap that they had to put their bathroom and their main office and their tank gauge all in one room here. And so that is, well, you know where it is, but it's kind of a funny position to be in. The picture on the right, you've got a Vito that's way up on the ceiling. So if you got to get a readout, you run the risk of falling on a ladder. Ladder falls are like a major occupational hazard. I think the state of Illinois has a requirement that says like the tank monitor can't be more than, say, 5 feet off the ground. So, you know, find the tank gauge is always kind of a game here. This poor fellow on the left here, I did a compliance inspection in Alaska years ago. We asked to see the guy's tank gauge. He goes, wait a minute. He goes into a closet, comes back out, and sets the darn thing on the table, not plugged in. Somebody like giving him the tank gauge was kind of trying to get around to plugging it in. And so here's a guy who's like, I don't know. I mean, I guess he had some good intentions here. He never got around to hooking it up, and so there basically was no leak detection. Picture on the right here. Yeah, maybe it's programmed. Yeah, maybe it's set up right. Yeah, maybe the guy's looking at the strip once a day here, but you can summarize that this is not a really well thought of tank monitor because someone didn't take the time to kind of store all the records here. I like to see little things like this, all Vito receipts here, and so they've got a little kind of crude box here. It's kind of overflowing with stuff, but they do have a TLS 450 Plus, and they do have somewhat of a loose filing cabinet system. And again, another picture here on the right here where it looks like we're kind of back by the freezer, and there's all sorts of merchandise and stuff on the ground. And so this is a site, again, where they've technically got a tank gauge, but it's not looking too hot. So again, I'll kind of end with just going over a couple of identifying factors here. 80% of the U.S. market or thereabouts is the Vito TLS 350 here. And what's good about this one here is that it's a common method. If you're an inspector, you'll come across this thing and you'll know right away what you're looking at. The good news is I'm seeing some little fine print notes here that are covering the TLS 350 thing, and so I'm going to give the operator points for trying to come up with a little shortcut list to try to help operators operate the system. The bad news is the sensor immediately to the right of the box, between that and the power box, is actually hooked up, and so when we get all functions normal, no sensor alarm for the sensor, it's technically true, but the sensor is actually not where it's supposed to be. Hold on, there we go. The Barco EMC, this is an older model. This is also considered a Vito. Once you open up the back door here, it's pretty much a Vito TLS 350 or 300 series. So tank monitors are getting away from buttons, and so we're kind of moving into what I like to call the iPad universe. And so we've now got color, we've got touch screens, and we've got visual graphics to show how much fuel is in each tank. And so these are great because you can immediately go in the back room and see what kind of tanks you got, how full they are, temperature, product level, water level, stuff like that. And so it's, pardon me, it's even been a push for me. The functionality, once you get behind the screen, is kind of the same. Me personally, I'm really interested in making sure that there's interfaces that are good for operators and inspectors alike to be able to understand. So if you're really used to the 350, the 450 is a bit of a jump here, but there's only a couple of navigational buttons on that blue bar on the left-hand side of the screen. So again, tank monitors are kind of moving away from the push-button technology and becoming more kind of modern age. This Vito TLS 450 Not Plus was only out for a short while. I'm not a big fan of this model. In fact, it was only out there a little bit. If you see the gray 450, it's not as good as the black 450 Plus. This one, the printer was really hard to read, and the navigational layout of the screen I found to be a little problematic, but they're out there. But again, it's another good Vito product. This is an interesting site because they actually have two tank gauges, and we've got the Vito TLS on one side, and I'm actually, it's an old Ronin system. Yeah, so you've got, and these are popular with a lot of the chains, and the Department of Defense had these for many, many years. So there's something interesting going on here because there's two different tank gauges and two different generations of those. The new Evo 550, TS 550 from Franklin Fueling is a great little device. Again, it's another simple touchscreen here, these are all customizable buttons, and so you can actually create kind of the screen view that you want. And the lower left-hand one says regulatory report, and if it's programmed properly, you push one button, you get all your compliance information from there. So I'm really excited to see more and more about these. It's funny, I was doing a Tank Savvy Minute video shoot for Franklin and got really kind of excited about this new console out here. When I was driving back home, I pulled into a little mom and pop gas station to get gas, and there was my first like real live in the field 550 box on the wall, and I was kind of chatting to the clerk saying, hey, you've got the new 550, and you know, the clerk was like, well, what are you talking about? I said, that box thing, and she goes, well, what does that do? I said, well, you know, it tells you fuel levels and leak tests and stuff like that, and she goes, okay, buddy, if you say so. I mean, this Class C operator had no idea what I was talking about at all, and so I just want to kind of plant that as a story for the work that still lies ahead of us for UST compliance. There briefly was a TS550. I've seen a couple of these out there. Again, we're kind of more in the push-button technology, but this one was, I think, short-lived as well and was replaced by the newer TS550. Incon's been around a while. They've got these old Incon 1000s. Typically, the 1000s have they've got good alarm capabilities, but they don't really say what the alarm is. So you could just be given a alarm warning and not know what it is until you drill down and actually print out an alarm history. This one's good though because it's got the business card of the installer that put it in, and so if they need help, and there's actually a phone number here of someone to call. So there's it's an older box, but it's got some good kind of managerial notes on it. The Incon TS1001 was a big improvement, and so you can get more. In fact, each of those little white boxes on the picture on the left here bring you right to a specific function, and so you can drill down a lot quicker this way. This TSLS 300 on the left is only for line leak detectors, and so if you've got this generation of Incon, you're actually going to need two boxes, the one on the left for the tanks and the interstitial, and the one on the right, which is a dedicated box just for electronic line leak detectors, and these can be daisy-chained together. So if you're a new inspector and you go to a site and you see these two boxes daisy-chained together, you don't automatically, you've got a electronic and not a mechanical line leak detector. Omnitech, these guys have a good product. I don't see a lot of those out in the field. We're kind of going into some of the lesser-known brands here. They've got a number of makes and models. This is an old, funny, these boxes came in and blocked out. We've got an old tank monitor here. This is probably from mid-'80s vintage. And Marcel, I might lean upon you for the name on that. This one got blanked. I've actually never seen one of these in the field. Here's this old Red Jacket. I think Vito bought these out, and they were paying people to retire these things. But the beauty of this one here is the sign that says, "Do not throw away anything that comes out of this printer. I need to see it. Thank you, Carla." So Carla may not know how to run this thing, but Carla knows that there is an important piece of information that's coming out of here. There is a brief run of these Red Jacket. I think these are like Pro Links, and super simple box, not a lot of buttons. The Eco 1500 series, these are not manufactured anymore. The buttons are pretty greasy here, so you can tell someone's been working this thing a lot. It is an alarm. C2 South sump alarm, and so we know that the sensors are C, it is a sump, and there is an alarm on the south sump. So this doesn't tell us a lot of information here. The printer's a little funky here, but this line has also been discontinued. EBW for a while had AutoStick and AutoStick Junior. These also were good because there were a number of buttons that allowed you to kind of, like quick navigational buttons that allowed you to kind of jump right in here. But you do have to become a little bit more fluent in the keypad operation. The hard part inspectors face is you have to become proficient in using the keypads on a wide variety of makes and models. And in 5 or 10 years, a lot of these lesser models will probably be gone. In fact, with the new mandatory certification of the ATG, for these devices that are not made anymore, if you can't get someone to certify that this old AutoStick Junior 4 is even still serviceable, this one might have to get decommissioned and replaced with a new one. So I think it's going to get easier in the future because there's just going to be a lot less of these old miscellaneous makes and models that are out there. A couple more resources for you out there. In 2000, which is a little bit of a while ago, EPA published a great reference manuals on how to get reports. I think it came out of Region 6 or 7, big fat book that's got a kind of a page-by-page summary of how to approach and how to get reports out of a variety of tank gauges. In fact, if you've got an older tank gauge here, this is probably the best resource here to help you walk through and know what reports look like and how to get them. And if you don't already know, I do this kind of fun thing called Tank Savvy Minute videos on YouTube, and I've got about 55 different videos. I've got a number of videos specifically on the Vito TLS 350 and the Franklin Evo 550 as well. I was recently contacted by Vito, and they're asking me when I'm coming out with my next line of videos for the TLS 450 Plus. I've got a site lined up. I've just got to set aside a little bit of time to go out and shoot some more videos. So hopefully that was a good summary here. Again, I'm trying to encourage inspectors to kind of think like an operator for a little bit, think about what that perspective means. So when you go out into a site, you can be of maximum help in getting them to kind of think a little bit more compliance-minded and increase their repertoire of this thing just being a business tool, this thing to being really an essential compliance instrument. And that's all I got, Drew. Thanks.
All right, awesome. Well, thank you so much, Ben, and a lot of useful pictures in there too. I did get a couple of questions, and I think as we walk through these too, just for the audience, feel free to continue to send me questions through the chat feature there. So the first one, Ben, and forgive me if you kind of ended up answering this as I was keeping track of the questions and things here, but so the question is, how far back in history can you go? And I assume that person's referring to the data that's being reported. So how far back in history can you go?
John might be able to help me a little bit more with that, but I know the older tank gauges had small hard drives, and therefore it'll save. If there's not a lot of alarms and you do leak detection monthly, you could conceivably go back to the beginning. So it depends on how active alarms get tracked. Because the older models, they would actually start to overwrite old history models. The newer ones, I believe, have a sufficient enough hard drive that you would never lose a source. So I think on average, when I print out an alarm history, I can usually go back to the beginning, or at least the beginning when the tank gauge is put in. But again, if it's a busy site with lots of alarms, after so many alarm stamps, it will overwrite the original report, and that history will be lost. And again, the newer ones, I don't think that's a problem anymore, but I'll lean on John or Marcel for more specifics.
Yeah, to kind of build on that, Ben, it kind of really depends on what report you're trying to look at. For most TLS 350s, for the alarm history report, it's going to store, I believe it's 40 lines of data. So,
okay.
It depends. If there's, 20 alarms in 1 month, hey, you're only going to be able to go back about a month because it's going to show when the alarm happened, when it cleared. So each alarm occurrence is going to take up 2 lines.
Gotcha. Okay.
And then it also depends on if the ATG has been cold started recently. If it has been, then you're going to lose that history that was in there unless, the operators printed all that information off and stored it in a spot where they can access it.
Excellent.
Awesome.
Thank you, Ben and Justin there. Any other responses from the rest of the panel? Anything else? Okay, great. Well, thanks for fielding the question, guys. I had another one here, and I'll defer to Ben first and then see if there's other comments from the panel. But the question, this person says, I have not found a manufacturer, and this might, sorry, backing up, this might be hard to answer because it's kind of posed to the manufacturer that's not on the panel here. But the question is, I've not found a manufacturer that defaults to alarm if the tank does not pass a 0.2 gallon per hour test. The alarm's disabled. How can we get manufacturers to default to alarm enabled?
Again, John and Marcel, I might ask for a little bit of a backup here. When you go to the setup, there's actually a couple of different settings. And one is alarm disabled, one is alarm audio disabled. And so it's possible that while it might look like it's disabled, it in fact is not. I worked on a case some years ago where there was the claim that someone had gone in and intentionally disabled the alarm notification feature. It was actually just the audio functionality, and the alarm itself was not disabled. I believe they come alarm enabled. John or Marcel or Justin, could you help me out with that?
I believe they come alarm enabled, but again, if something gets cold started, somebody changes programming and, accidentally hits the wrong button, those in-tank leak test history, those alarms could become disabled. The operator doesn't know it. They go on about their business. And, you know, it's just one of those things that it never comes up. They just assume, hey, we never got an alarm. We're good. So it really goes back to making sure that that tank monitor is programmed correctly when it's installed, and that, you know, if it is cold started and a tech comes out and reboots the system, that they're going through those settings to make sure that everything is set up properly based on the equipment that's at that site.
John, Justin, to the best of your knowledge, though, they should come alarm enabled from the factory, right?
Correct.
Well, I disagree. This is Marcel. I mean, I know that I haven't done a survey of all the tank manufacturers, but I have dealt with several cases where the default programming, and this may have been a certain period of time for a certain manufacturer, but the default program was that the alarm was disabled, and that if you wanted the tank gauge to notify whoever was on site that a test had failed or whatever, you had to specifically enable the alarm. Otherwise, the default was to have it not enabled. So I don't know the current status, but I know that historically, there have been at least a period of time when it took an active programming effort on the part of whoever set the thing up to enable the alarm. Otherwise, it would be silent.
Okay.
All right. Thanks, panel. Kind of a tricky one to answer there, but there's different perspectives for the person who asked and the rest of the audience. So I'm going to go ahead and get to one more here. I think we're making good time, and then we'll move forward. And again, great questions. Keep them coming. This is great. So this question, it's kind of a question, and it's followed up by some further explanation. So the question is it okay for sensors to be in normally closed position? Normally closed position. And what they're saying is, I get pushback from service providers that sometimes this is how a sensor needs to be set up to work properly, but like in the case of Vito, this setup is not okay. As an inspector, how much should I push back on this? And I can read it again if it helps.
I'm not familiar with the term normally closed. Marcel or Justin?
Yeah, I think that need a little more background here, but here's what I think is going on, right? When your sensors, the early sensors were all normally open, which meant that basically the sensor is a switch, and when the switch contacts are apart, it's called open, and when the switch contacts are closed and complete the circuit, that is called closed. The early switches, the early sensors were normally open, which meant that the switch did not complete a circuit in the normal position. So the circuit was only completed when the float moved and the switch contacts were closed by magnetic field. But then it was written that for a normally open sensor, you could cut the wires, right? You could totally disconnect the sensor and it would read normal back at the tank gauge because it didn't know any better. So more recent sensors are normally closed. In other words, the circuit is complete in the normal position, right, when no liquids are present. And then when a liquid is present, the circuit is broken, right, and it's the breaking of the circuit that triggers the alarm. So with a normally closed sensor, if you were to cut the wires, that would sound an alarm, right, and that would tell you that something was wrong. So the normally closed approach is better because it enables you to do some troubleshooting of the sensor automatically by the tank gauge. So normally closed or normally open, there's no good or bad. It depends on what type of sensor you have. An older sensor, then normally open is the way it should be. And if you have a newer sensor, then normally closed is probably the way it should be. And that might also depend on whether it's an optical sensor versus a reed switch. So you need more information about the exact type of sensor that's installed in order to tell whether normally closed or normally open is the correct position.
Okay, great. Well, thanks for the the feedback there, Marcel and the rest of the panel. And yeah, maybe some more clarity on the question would be helpful. So feel free to follow up there, whoever asked that, and you can always circle back with me after, and I can help put you in touch with folks in the panel if you want to keep the conversation going. But again, thanks so much. So that's going to be a wrap just for now on the Q&A. And again, folks, please keep the questions coming. Keeping our speakers on their toes, that's why they're here, and I'm sure they appreciate it. So thank you so much, Ben, for filling out the middle of the training here and giving us your perspective. And I'm glad that the questions are kind of picking up here, because with the kind of the third part of the presentation today, we're going to be maybe a bit more interactive. I'm excited to later in the presentation have some polling. So those of you out there in the audience, this is something that's new as far as our webinars, but I'm looking forward to getting you involved in that way. So we'll wait on that. Should be pretty straightforward, and we'll get to the polls in a bit. So with that, it's my pleasure to introduce our third and fourth panelists today. They're going to be speaking as a tag team group. It's my pleasure to welcome John Kelly and Justin Whitfield with Canary Compliance. I'll go ahead and pass you the controls now, John.
Hey, can you hear us okay?
Yes. Yep.
Okay, good. Yeah, good afternoon, everybody. This is John Kelly, and I'm here with my colleague Justin Whitfield, who you already heard from a little bit on some of those questions earlier. Thanks to Marcel and to Ben for their input on this, and hopefully laid some groundwork in terms of how ATGs work, why they exist, and some of the common things that we see out there in the field. Justin and I are going to be focused on a couple of things this afternoon, which are the alarms that actually go off on the Vito route, or the ATG, or the loud thing in the back, and then how people respond to them and why they may respond to them in different ways. As Ben has alluded to, a lot of times these operators that are in the store don't really understand the equipment very well. They don't really know what to do when something beeps or goes into alarm, and they also have a lot of other things to deal with while they're in the store. So our objective today is to hopefully take some of these topics and then ground them a little bit in reality, because I think there's often a little bit of a disconnect between operators and regulators. I think in the world of underground storage tanks, the EPA and the states have done a pretty good job, working to create, sort of bridge the gap, having things like this to expose regulators to the industry's perspective, and vice versa. Being very proactive at the PEI convention and MAX and stuff like that to make sure they're constantly engaged with the regulated community. But our goal today is to continue to work and build that bridge of understanding and knowledge between regulators and what goes on day to day in the field. So I think it might be helpful for Justin just quickly to give a quick intro and talk about, he's spent a few years with 7-Eleven, and one of the things that they do when they bring you on a 7-Eleven is they put you in a store for 2 weeks. And I just think it's interesting, Justin's perspective on it. I'll just ask him to kind of share it to start things off here.
Yeah, thanks, John. So as John mentioned, I spent a handful of years at 7-Eleven in the environmental compliance department. And as you mentioned, one of the things that you do there is you spend 2 weeks operating a store, just like you're a store clerk. So one of the interesting things is, I was in the environmental department, and, I was a regulator before, and like, how do these operators not get it? It's not that difficult. There's not, it's just keep your records, respond to alarms. But once you get there, you start to realize that at a normal convenience store, there's 2, maybe 3 people working at a time. Those people are, ringing up customers. They're getting cigarettes for customers. Nowadays, with all the fresh food, they're cooking sandwiches, pizzas, hot wings, all of these things that go into it. And then they're also ordering candy bars to make sure that on the next order that, they have enough Snickers, they have enough Twix. And then the ATG is beeping in the back. Well, during the morning rush, the lunch rush, the evening rush, you don't have time to run back there, see what it is, dive deeper into it to say, okay, what does this specific alarm mean? How should I respond to it? Really, your focus as an operator is on these customers, making sure that whenever they come into the store, they have a good experience. compliance kind of gets pushed off into the back burner, so to speak, from an operator's perspective, just because they know that I need to have fuel on the ground, and when my customers come in, I need to have what they want and how much of it they want.
Yeah, I think one of the interesting things that Justin also mentioned was, while he was in a store, I think he said 4 or 5 different inspectors came in one afternoon. Weights and measures, UST, food inspectors, health and safety, all kinds of different stuff that go on and all kinds of different things that are beeping at the same time. So it could be the microwave, could be the door opening and closing, could be the ATG, very tough to discern what it is that needs to get responded to. But anyway, I think that's always kind of helpful just to kind of lay it in sort of ground things in reality a little bit. So as Drew mentioned, as we move into the presentation here, one of the things we wanted to do was kind of get some perspective from the audience. And the first thing that we're going to do is a poll question. Drew, are you ready to fire that up?
Yes. And I'm still seeing your intro slide or your picture slides, but whenever you're ready to put the question slide, or maybe it's just a voiced question, but whenever you're ready, I'm ready. Yep.
Yeah, so one of the things we want to do is to get some perspective from folks about how many ATG alarms occur per month at a retail facility. And this is kind of, sort of on average, industry-wide. We've done a survey of this and just kind of wanted to get some thoughts from the audience. So, Drew, if you're ready to get that poll question out, we can let the audience respond to what they think. And I think we're going to sort of let it run for a few seconds here. So if folks want to respond to the poll that's on the right side of your WebEx, we'd love to get your input on this one. We're going to give it sort of 20, 30 seconds, Drew, and
yep. Yeah.
Do we have a decent sample size there, Drew?
Yeah, I think we do. Let's go ahead and close this.
Right. All right, so the question is, on average, how many ATG alarms occur per month at a retail facility? Less than 1, between 1 and 5, between 5 and 10, or more than 10? And what did the audience say?
Yep, I'm going to go ahead and pull it up right now.
Okie doke. So we've got most of the people that did answer the question say between 5 and 10. Nobody thinks it's less than 1. That's good. But of the 82 respondents, 23 think it's between 5 and 10. 20 think it's above 10. So interesting, very good. Sounds like you guys have been to gas stations before. It's great. So we'll flip to the next slide, which kind of gives us the answer here. The answer is actually above 20. We did a study of 700 gas stations over the course of 2 months, and there were 30,000 total ATG alarms over the course of that 2-month period, which averages out to about 20 per site, which is kind of a crazy number when you think about it. It's almost 1 a day that's going off, and that's in addition to all these other things. And we were looking at those numbers and thinking, my goodness, that's a huge number of alarms that are going off. Surely not all of them can be related to leaks and compliance. And so what we did was we filtered out all the stuff that was related to paper jams and paper out and low product delivery needed, things that are not associated with compliance. And we were to filter it down to about 17,000 compliance-related alarms. And this is still a very high number of alarms that are going off. But what we started to do was talk to our customers and service providers and stuff like that to really figure out what's going on here. And what we determined was that although all these individual alarms were going off, in some cases, it's not necessarily an alarm that's the individual data point that's significant. It's the trend or the pattern, which is indicative of a contextual or conditional issue at the site. So, for instance, there might be 17,000 compliance-related alarms going off at these 700 sites, but when the wiring on a sensor, and we've talked about sensors earlier, when the wiring on a sensor goes bad, that sensor can go in and out of alarm every minute for days until it gets addressed. And so that was what we were capturing here in this high number. And so sometimes you might see 800, sensor fuel alarms. And to the question earlier about how much history is stored, when that starts to happen, it eliminates all the other alarm history that's going off because you've got the same recurring problem time and time again going in and out of alarm. The same problem can happen with tank probes where wiring goes bad and it goes in and out of alarm continuously until somebody gets out there to address it. The other thing that we thought was very interesting is that when you might look at the site's alarm history and you might see that every single alarm at the site went off on the same day. And that's not necessarily indicative of any kind of compliance-related issue. It may, in fact, indicate that on that day, there was a service contractor conducting compliance testing, and they intentionally put every single piece of equipment into alarm to make sure that the functionality still works. And so that's another example where there's, increasing numbers of these alarms, but it's not necessarily indicative of a problem at the site. It's indicative of someone testing and making sure the equipment works. And that functionality testing happens on an annual basis, so, you'll see that from time to time. There are other issues that we see where you might see a different, the same alarm in different contexts may mean very different things. If you have a site where it has a high water table, it rains all the time, and they have water intrusion problems in their sump, they may get a sensor alarm every single time that it rains. And, if that's happening and, it's pouring with rain outside, operator might just say, okay, well, it's probably just water in the sump again. If you have water in the sump, then, that is what it is. You've still got to get it out. But that's one thing, and it's not necessarily a fuel-related issue. You could have the same sensor alarm that goes off. If that sensor alarm happens in conjunction with a PLLD alarm at the site, what that would mean is that not only is the sensor alarm going off, but it's also the PLLD alarm going off, which indicates that there is some kind of a fuel-related issue at the site, and that's something that you need to address immediately as a high-priority issue. So the same alarm, an L4 sensor, for instance, could have two very different levels of significance for an operator when they see it in conjunction with other things. Now, that's just to kind of give some context around these different alarms, how many are going off, and as you heard from Justin, the beeping all the time sort of takes a back seat for an operator when they're on site dealing with everything else that's happening at the store. So hopefully that kind of gives you a sense of the volume of these things, and we look at this and say, well, the more of these alarms that go off, the higher the site's risk profile is, because there's more noise that they need to decipher through in order to figure out what's really going on. We thought this was kind of interesting and hopefully some helpful context for you all as you're out and about dealing with the regulated community. Hopefully it gives you some kind of understanding of what they're dealing with in terms of the volume of these alarms that are occurring. Okay, so the next question that I have, unless there are any questions specifically on this alarm volume stuff, Drew, we just keep moving forward?
Come in.
Cool. Is on average, how long do ATG alarms remain active? Another poll question, which I think Drew has opened up: less than a day, 1 to 2 days, 2 to 7 days, or more than a week? Drew, let us know when you think you've got a good number of responses.
All right. All right, here we go with the results.
Great. Okay, so, yep, we see them. 2 to 7 days or more than a week. 19 out of 82 people say 2 to 7 days. 23 out of 82 people say more than a week. Interesting. So we also wanted to share some study data from 100 sites over the course of 6 months, because we think that alarm response time is really indicative of a site's risk profile. And so what we did was, in this example, we took out all alarms that were active for less than 24 hours, because that captures a lot of those kind of wiring issues that I talked about earlier, where it'll be active for a minute or 5 minutes or something, and then inactive. We wanted to see about things that were active for a long time. So this is a variety of different types of ATG alarm that you might see, from CSLD rate increase warnings, high water alarms, and all the rest that you can read on the screen there. But over the course of 6 months at 100 sites, excluding anything active for less than 24 hours, we looked at how frequently these alarms were occurring, and then how many days were those alarms active. And you can see that it's kind of generally between 2 and 7 days for these things, where they'll happen, and then maybe someone responds to it, maybe they don't. The ones that are quite concerning are when you start to see these high water issues that are lingering, the sensor fuel alarms that are lasting for a long time, meaning that there is liquid in a sump or in an interstitial space that needs to be addressed, and someone's not getting to it for 3 or more days. Certainly creates a risky situation. There was a story of a gas station in Chicago, I believe, about 2 years ago, where they didn't go and address an issue where water was in a sump. It got into the waterway. It sort of made its way into the water system, and about, I think it was 12 or 13 miles down the road, there was an explosion when the fumes sort of got sparked and ignited, blew off a couple of manhole covers, and actually got into an apartment building, and there was a person downstairs, I think, using some laundry machine, and it ignited the fumes and caused a fire in the building. So really serious things can happen as a consequence of all of this. I'm sure you're all aware of it. It's why these activities are regulated in such a stringent way. But I guess the question is, well, why are these things lingering for so long? What is it that makes it so that operators don't do this? We don't think that any of them are hoping to, cause problems, but the reality of dispatching a service contractor to come and address an issue when you have all these other things going on is something that they need to deal with. And we should have had another poll question for this, but the average cost of a dispatch to roll a truck out to a store is somewhere between $200 and $350 just to get somebody out there and to spend an hour or so on site investigating. And so for many of the operators that you're dealing with, to have someone come out and address it, it's much cheaper for them just to put the sensor in a Slurpee cup like we saw on Marcel's slide, even if it creates a little bit of extra risk for them. And in many cases, that's what they do. So it's kind of interesting context, we thought, sort of to share how long these things were lingering, start to understand why they're lingering for so long, but the realities of running a convenience store and a gas station, and the amount of money that these guys have to deal with, and extra cash flow, doesn't always necessarily allow them to prioritize having someone come out to take care of a Vito alarm when they may or may not even know what it means. So we thought this was very interesting information, hopefully kind of gives you some additional context as well. So as we keep rolling, one of the other questions that we wanted to ask is a simple true or false question. ATG alarms always accurately represent what is occurring at the site, true or false? All right, Drew. Okay, so false. Yes, that is the correct answer. ATG alarms do not always accurately represent what is occurring at the site. Now, why is that? Well, we're a remote tank monitoring company, and one of the things that we're able to see is what people's settings are and whether they are sort of lined up in accordance with what would be considered industry best practices. And that's something that we've aggregated from, a number of different sources, service contractors, consultants, regulators, stuff like that. But it's shocking sometimes what you see when you actually probe into what is going on with the setting. And when the underlying data has no integrity, that is also another reason why these alarms go off so frequently, is because the water limit might be set too low, or it might be set too high, or whatever. The high product alert might be set too low. And, so many times people will say, okay, well, it's just crying wolf again, that they choose to ignore it. And we just wanted to kind of share this with you, because when you're looking at an alarm history report, one of the critical things to understand is, well, was the setting actually programmed correctly? Oftentimes a high product alarm of 95%, we see them programmed at 59% because somebody just fat fingered it while they were, programming it on the Vito route. And so in that case, you'd have a high product alarm going off every single time you had a delivery pretty much. But We think it's one of those things that there's a difference between signal and noise, and if the underlying settings are not correct, we've talked about that a little bit today, it can create an awful lot of noise and make people feel like the ATG is crying wolf, another reason why they may not respond to it in a timely fashion. So there are lots of, obviously good service contractors that are out there, and even the best of them, however, can be undermined when, an operator goes back and silences an alarm or disables the alarms or something like that, or reprograms the settings to a different level so they don't see anything. So certainly encourage you folks to sort of keep that in mind as you're out there in the field, doing inspections and stuff like that, and making sure that settings are always programmed correctly to the best of your ability. But anyway, we thought that was another important part of the alarm response sort of puzzle, I suppose, is the data integrity. So I guess we can kind of keep moving along. Do you have anything to add on that, Justin?
No, I mean, nothing too much to add to it. It's just, really the programming when this ATG is installed is really important, and that's going to lead to the operator being notified when certain things are going on at the site. So being able to verify these settings and know what they're actually set at, helps the operator to know that, hey, this is a legitimate alarm that's happening.
Right, exactly. And this data right here that we pulled is from, sort of 50 sites or so, but it's pretty representative of what we see when we're out there in larger sample sizes as well. So something to be aware of. So we're going to move now from alarms into reporting. And so the next question that we have is, this is a screenshot of some tank leak test history. And we are going to ask you folks, is this site passing? Yes, no, it depends, or beats me. And I think Drew's shortened the time limit on these questions down to 15 seconds. So make sure you're quick on your response. So we only got a few answers that time, but a few people said it depends. And that is the right answer, at least from our perspective. So it kind of depends on when this report is printed out. As you can see, this is quite a complicated report. What does it really mean? And, sort of historical tank leak test history is a little bit difficult to decipher. But what you have to consider in this case is when the last when this report was actually printed out. Given that it says the last test passed on October 20th, 2015, we can assume, around then is when it would have passed, or what is when it was from. And so in this case, at the moment, this site is passing because it has the October 14th, 2015 result there as part of its history. However, if this had been printed, in November of November 20th of 2015, and it didn't have a passing result from the month of November, then that would indicate that it was not passing at the time. So it's very important to understand kind of what is actually being assessed and measured. And for a Class C operator to look at this and to interpret it, I think it's kind of a big ask in some cases, because this isn't exactly intuitive to people. And one of the things that we often see is there's a debate out there between regulators and the regulated community and between different states and all of that, discussing whether compliance is a monthly thing, whether it's a rolling 30-day calendar. And I wanted to let Justin talk a little bit about that concept, because it is something that's a bit thorny for people.
Yeah, so looking at these reports, is the site passing? It depends. If you're looking for a rolling 30-day window of pass results, the site, as you go down the list, hey, pass on January 30th, then February 23rd, then March 1st, and then April 4th. Well, it didn't fall in that 30-day window. But when you look at this report, it's just reporting the fullest test pass for each month. So that's not saying that there weren't other tests that passed that month. This is just documenting and recording the fullest. So it's important to know which report the operator is providing you. It's important to know which report is being printed out and that you're looking at. That way you can actually get a good feel for, is this passing? Is it meeting those rolling 30-day periods?
Thanks, Justin. And this is, one of the reasons that we sort of approach things from a very alarm-centric perspective is that we think that, if you're addressing your alarms and you're taking care of things as they occur and problems as they arise and issues as they happen, then your sort of monthly passing results at the end of the month should really kind of take care of themselves. It's kind of too late if you're checking your passing results to see if you pass and crossing your fingers after the fact. If you're addressing alarms up front, you end up not running into those types of problems. So the next question, kind of similar. Is this site passing? Yes, no, it depends, beats me, I guess 15 seconds if we want to get this one on the clock.
Yeah, I'm gonna give you guys a little more time on this so you don't injure yourselves trying to quickly answer these, but I'll go ahead and open this up. So 30 seconds there.
All right. It depends and beats me are the winners. Yeah, that would be my response as well, either of those ones. I think, sort of it depends on what you find in this box, and then even when you do look into this little box, you got to sort of leaf through it and see if you can find what it is that you're even looking for. But, I'm sure you guys have seen these types of things, these shoe boxes under the Vito root that are catching reports. Oftentimes what happens is people they print them, they rip them off, and they put them in there, don't even look at them. And in that case, you're always running a big risk of just ignoring alarms and then not having any passing results from operator. So very important to make sure that you are reacting to things. And that's why you see more and more people moving to sort of remote types of systems where they can ensure that even if the person on site is not well versed in how to respond to these things and what to look for, somebody who's properly trained is able to react and respond to these things as well. So that this wasn't really a super serious one, but just to kind of give you a sense of what people deal with in the real world. The last bit that we'll just touch on quickly, and I'm going to loop Marcel a little bit into this conversation because we're working with him on it. The industry, as we mentioned, there are some real challenges around data integrity when it comes to the programming and the Vito roots. I'm sure that many of you regulators out there struggle with people registering their equipment and having a good sense of what is actually stored underground in terms of what types of equipment, how old is it, how long has it been there, what's it made of, all that type of stuff. And so we've been working with Connexus, which is an organization that's spun out of NACS, the National Association of Convenience Stores. They're focused on building digital data standards for the industry. They've done things for point-of-sale systems and all of that. We're working with them and our friends at the Petroleum Equipment Institute, and Marcel is the sort of key representative from PEI that's involved in this initiative. We're working to build out a digital data standard which will sort of create a common language for how people refer to underground storage tank equipment when they're storing it online. The goal of this is really to make it easier for people to transmit, share, analyze, and process their underground storage tank equipment data. And, we're really hopeful that this will lend itself to sort of greater data integrity in the future so that people don't run into problems when they're, trying to figure out what they have, how much of something they have, and all of that. But Marcel, do you want to add any comments on this effort that we're working on at the moment?
Sure. So this does not specifically relate to automatic tank gauges, but it's a similar issue for folks like Canary who are trying to read all these different customers' databases in terms of what equipment is present at the site so they can better understand, what the ATG is telling them about what is actually happening there. So PEI has teamed up with Connexus, as Sharon said, a branch of the National Association of Convenience Stores to try and develop or work on developing a standard that will sort of create a uniform language for online databases so that when a STIP3 tank gets entered into a database, it gets entered as, under the same terminology. It's not an STIP3 in one database and a galvanically protected steel tank in another database and a UL58 with galvanic protection in another database, so that all databases refer to the same equipment with the same terminology, so that it becomes much easier to understand that information and also to move that information around. So this is I think a medium-term effort in terms of developing a standard, and probably a very long-term effort in terms of getting the standard actually implemented out there in the real world. But we've got to start somewhere, and hopefully this will help in down the road in helping computers and organizations like Canary and even regulatory agencies communicate with one another about what equipment is actually present at a site.
Yeah, thanks, Marcel. One of the things that we did as part of the sort of initial scoping of this effort was we met with the EPA folks, with Mark Barolo and Tony Rea down in D.C. to discuss this because, certainly we think that there is a place for better data integrity when it comes to analyzing and interpreting, reports of what's actually on the ground. If there are things like product recalls and stuff like that, it helps to know where this stuff is and to have a common language so that you can analyze it. But we just wanted to kind of share this as something that's being undertaken by the industry right now, because as more and more stuff moves online, objective is to make it as easy as possible and to eliminate as much risk as possible associated with this very high risk equipment that we've got all over the country that we need to sort of work hard to ensure is managed properly. So with that, hopefully you found our discussion here on alarms and some of the data that we found to be interesting and useful and relevant. I will hand it back over to Drew unless there are any specific questions.
Great. Well, thank you so much, John and Justin, for your perspective. Great presentation. I just saw my Q&A light up, so I'll check that in a minute. But yeah, so I did get a good question here, and I'll start with John and Justin, and then we'll see. I think the direction we're going here is hear from the rest of the panel as well, Ben and Marcel, if you have anything to add. So the question here, I'd love to understand what CSLD rate increase warning means, especially since that alarm seems to get ignored for a long time.
So in kind of general terms, the CSLD tests that have been running and the rate table that's been building is showing that there is an increase in the level of volume during those tests. Now, depending on the type of equipment that's out there, it could be that, hey, there's a water ingress into the tank during these tests. It could be that, there's two tanks that are siphon manifolded. You're getting a little bleed back in that siphon bar. It could be that there's, a little bit of bleed back into the tank whenever the fuel is dispensed out to the dispensers. And usually what happens is, the operator may go out, they may clear their rate tables to get those to rebuild and try and get that CSLD test to pass for those tanks. CSLD rate tables can take up to about 2 weeks to build. So while that's getting built out, that rate table, those alarms are going to stay active. So this is one that happens a lot. It kind of sits there and stays active for a while on that tank monitor. But just like anything with these ATGs, there can be a lot of different causes that's actually causing this issue. And it takes, investigations, sometimes multiple investigations to figure out exactly what is causing that specific alarm.
Marcel, was our technical interpretation of that up to scratch?
That was fairly technical. To put it a little more in layman's terms, the rate increase warning is basically telling you that during a test period, the fuel level is going up, not down, but up. All right, so unless we're talking about a high water table situation where water's coming in, all right, that's probably the only situation I can think of where that's an actual environmental issue or environmental problem. My own interpretation of that particular warning is that I think I would say in a great many cases, what's happening is the fuel is bleeding back from the piping into the tank. Right, so there's been dispensing, and maybe the check valve didn't speak quite 100%, so fuel in the piping is bleeding back into the tank, and that's causing a very slow increase in the fuel level in the tank, all right, but doing a fitness test. So we're watching for those small increases. Or it could be a hot day, we've got cool product in the ground, we just put it in some hot piping under that black asphalt, so there's a thermal effect, the product is heating up in the pipe, and so the pressure release mechanism in the check valve is allowing product to go from the piping back into the tank. Or it could also be, product switching from tank to tank, that kind of stuff. So I think from an environmental perspective, unless you're in Florida with really high water tables, this rate increase not particularly an environmental concern, but it is an operational concern because if you have a consistent flow of product back into the tank, you could then mask a leak that actually occurs, right? Because you're losing out the bottom and gaining at the top. When in fact there's a leak going on. So it's an operational issue, but I don't think the alarm itself, is a cause for immediate concern unless there's a high water table.
Oh, all right. Great. I mean, we got a thumbs up for the person that asked the question, so great answer then to the panel. So I do have another question here. I just want to put out there to the audience again, a really great opportunity here to ask, 4 very knowledgeable speakers, about this topic. So I really encourage you. I'll keep you anonymous, but please send me any questions you have. Still got a little time here to answer those. So use the chat function and send the question away. So the question, and this will be for the whole panel, I think. Someone's looking for recommendations. So the question, what are good industry conferences for regulators to attend to learn more about equipment and be available for interface between regulators, owners, and manufacturers?
I'll go ahead and start. This is John. I would say that the NAC show, the National Association of Convenience Stores, is the biggest. That happens once a year. This year it's happening in Atlanta in October. They also bring, PEI also has a convention that runs simultaneously to the National Association of Convenience Stores. And so that's really the optimum time and place to get in front of convenience store operators, service contractors, the actual equipment manufacturers, as well as any other kind of service providers in the industry. That's kind of the mecca of all of it right there. That would be my first recommendation. There are lots of regional shows that sort of either big regional groups throw on. In the Midwest, there's MPAC, there's the Eastern Energy Expo, kind of in the Mid-Atlantic. New England has another one, I think. But, lots of state associations throw trade shows. Trade show activity generally runs from February through about May, and then picks up again between sort of October and the end of the year. Those would be my suggestions. Also, the National Tanks Conference is a good one, but that only happens every couple of years, right, Drew?
Correct. Yeah, I promise I didn't plant that question, but yeah, I was going to chime in and say, yeah, National Tanks Conference. It's there is an exhibit, and we typically have anywhere from 35 to 40 industry representatives there. We've yet to announce when and where the next one will be. I think I mentioned at the SWOMO mid-year meeting in April that we were and we continue to be planning for September of 2020. So we're about 13 months out if things go as planned. So we will make sure to announce that in due time. Any other recommendations from the rest of the panel as far as things you've been to?
I would agree with John at the PEI show. If you can only go to one, I would make every effort to get to the PEI at the next show. And my second bit of advice is that, the manufacturers, and the biggest thing for me at the PI show is always talking to the manufacturers and not the sales engineers, the people who actually built this equipment are sometimes present at the PI Next show where they might not be present at smaller shows. And if you have technical questions, they're the ones that you really want to talk to about how this stuff really works. And my second bit of advice is to go on the last day of the show, not the first day, because if you're wearing a tag that identifies you as a regulator, these people are there to talk to and buy their equipment. So they will tend to pass you over. But on the last day, the crowd's thin, and people are much more willing to speak to regulators and other consultants like me and other folks who are not in a buying position, but in a position to want to know about their equipment and or talk about their equipment to regulators or owner-operators.
And this is Ben. I would echo, pardon me, what everyone else has said. The PEI show really is the premier national source, and I'm always surprised at how few regulators and inspectors are there. I know that over the last couple of years, there's been like an EPA roundtable session whereby you can go and meet the heads of EPA's UST program, as well as other state inspectors who have made it there. So they're in between talking to the vendors, and I appreciate Marcel talking about the manufacturers and going in on Sunday, but there are places to gather to compare notes with other regulators as well. And also, if you can find a local Petroleum Marketer Association trade show, that's probably good. It'll probably be more convenience store merchandise than, say, Veeder-Root or Incon or the major manufacturers. But if you can only travel in state, then going to your local petroleum marketers group is a great way to go.
All right. Thank you all for those responses. I'm kind of setting up another question here. I think we've got time for more. So again, encouraging folks to ask questions of the panel, and just give me 1 second here to pull this up on my screen. All right, so a bit of a wordier question, so bear with me as I read through this one, and I can definitely repeat the question if it helps. The question, the National Work Group, so NEIWPCC National Work Group on Leak Detection and Evaluation, third-party certification only uses a probability of detection of 99%. Is there another third-party certification that allows a 95% probability of detection? And then the follow-up question is, same with the SCALD volume, SCALD volume quantifier of 14%. If these are not set to a third-party certification, should it be considered an invalid test? Would it help if I just read the first one again?
Well, I think I can provide a little background. I might clarify that question. Is that the CSLD in Veeder-Root, you can program it to either do a 95% probability of detection, which is the minimum requirement of the rule, or you can also program it to do 99% probability of detection, which is what Veeder-Root chose to do when they went to Ken Wilcox, had him do the evaluation. So the reason the work group only approved the 99 is because they were only presented with a 99% probability of detection. Right, because that's the only one that Veeder-Root paid to have performed. Not that it doesn't work at 95%, it's that the only information that the work group has to work with is based on a probability of detection of 99%. So going back to the federal rule and the requirement that equipment be certified by the manufacturer, the 99% is the only level that has been certified by the manufacturer. Not that 95 doesn't work, just that 99 is the only one that's been certified. So technically 99 is the only percentage that is 100% compliant with the rule, and it's probably what you should require when you're looking at the setup programming for a tank gauge. Right? So it's not that 95% certification by a third party has not been done. Right? So it does not meet that particular requirement of the rule, and if you're a stickler for detail, you would not consider that to be compliant with the regulations.
Okay, thank you, Marcel. I'm not getting any other questions. I only have a very short wrap-up, so I think we have time for one more. I'll offer it up to whoever has the fastest question to come in, because again, I want you to be able to take advantage of the opportunity with these folks on the line. So again, time for one more question or maybe two more quick ones. Let me just give it a minute here, see if anyone bites, and then we'll wrap if not. 1 minute for final questions, folks. I think I got a quick one, Ben, directed to you. So the question is about your tank savvy minutes. Do you have a favorite tank savvy minute or one that you would recommend?
Do I have a favorite tank savvy minute?
Yes.
I don't know. I mean, they all speak to if you got the time, you might just want to kind of grind through them one at a time. If you're a new inspector, then you'd want to start at the beginning, which kind of, you walk onto a site and you identify the number of tanks by the number of lids and colored lids and whatnot like that. So, I mean, I've had some funny ones over the years where, I don't know, I'm filming and some crazy person walks into the shoot and is kind of in the background. But I mean, yeah, there's really kind of something there for everyone. So I would say that, yeah, I would say start at the beginning and just work your way through. And hopefully there's some good nuggets in there for you.
That was my question, Ben. I really like Ben's Tank Savvy Minute videos, so I encourage everyone to check them out. They're very informative.
Thanks,
yeah, and I should have mentioned, and hopefully you all saw kind of as you navigated to the link to log in today, but I did put up a few resources that, from our speakers and other places. So we had a couple of Ben's videos up there, some articles, links to articles that Marcel had mentioned that he wrote for Lustline. I think was mentioned earlier on this webinar. Canary puts together some kind of fun and informative videos on what they do. And so if it's helpful, I definitely plan to go ahead and pull those over with the archives. So right now they'll still stay on the upcoming webinars page until I move that. And I'll get to that next steps in a minute, but just an FYI, some links to videos there, and I can include those with the archive if our speakers say that's okay. So we're going to go ahead and wrap, and I will pull up the speaker information in a bit. So if we didn't get to one of your questions today, we're educating today and also planting the seeds. So we definitely encourage continued conversations, direct them to me or our speakers. So I'll go ahead and take the controls back and we'll go ahead and wrap for the day. So I want to wrap with a huge thank you to our speakers today on the panel, Marcel, Ben, John, Justin. Thanks so much for putting in the effort to create and deliver what I think, and I hope our audience agrees, was a really informative session today. Some great perspectives and good information there, and really proud to go ahead and put this up on the archive for folks to continue to view in the future. Thank you so much for your work today. I think I just mentioned, well, actually backing up, when you X out of the screen today, you'll be automatically prompted. There's an opportunity to provide any feedback that's general about the training. It's specific to the speakers, recommend future training